Hi everyone, we are in section 11.9. This will be the last section of chapter 11 that we're going to cover. In this section, we're looking at polynomial inequalities and rational inequalities. As for your homework goes, the homework pages are page 765 and page 766. So again, let me show you those two pages. On page 765, of course, you're looking at problems that are in this range in part B. These are the problems, I believe you're doing number 13. Of course, I'll do ones like these with you, for you. And on the following page, that's page 766, you're going to take a look at the continuation of problems in this segment. I believe you're doing number 23. And then further down, we're looking at, let me go to where the problems stop, right about here. We're going to look at this segment, part B, rational inequalities also. We may take a look at a couple of these exercises. I believe the one you're doing is number 37 on this page. Okay, so let me go actually to our notebook and we'll begin our instructions. So in this section, again, we're going to take a look at, in the beginning, polynomial inequalities. Now, there are these types of inequalities. So if you recall, the inequalities are less than, greater than, less than or equal, greater than or equal. So we're going to be looking at these kinds of inequalities. And we're going to take a look at, in the beginning, polynomials. Then we're going to look at the rational or fractions. So I'm going to go right to the exercises to show you how this is done. Again, let me change my notebook to where I have some lines and change the color for you so it'll be easier on your eyes. And let's begin. So I'm going to go ahead and begin with exercise number 14. So in exercise number 14, the inequality is x plus 8 times x plus 10, and that is greater than 0. So remember, greater than 10, greater than 0 means positive, right? Because anything that's a number bigger than 0 has to be positive. Now, as far as how we're going to work these, all the exercises in this section, this is how we want to do them. We want to make sure, first of all, we need to make sure two things are in place before we can actually solve these inequalities. The two things that must be in place, number one, first, we got to make sure that we have 0. So we're going to write, we must have number 0. Okay, this is number 0. We must have 0 on the right side. On the right side. That's very important, number 1. And number 2, once we have 0 on the right side, to the right of inequality, number 2, the expression that's on the left side, expression on left side, whatever that may be, okay, on the left side, this must be in factored form. Factored form. Okay, so those are the two things that must be definitely in place. You gotta have a 0 on the right side and you gotta have the factored form. Okay, now if you take a look at number 14, for instance, we do have, first of all, 0. That's first and foremost. Which one is priority? 0. First thing, 0. Okay, so for first 0. Then on the other side, we need to have the factored form, which we do in this case. That means multiplication. Now, once those two things are in place, here's how we're going to actually work these. We're going to set each factor equal to 0. So I have x plus 8 equals 0 or x plus 10 equals 0. And then we're going to solve x is negative 8 and x is negative 10. Okay, so we found the numbers that make each factor 0, correct? Now, once we have these two numbers, I'm going to draw these two numbers. Actually, not draw them. I'm going to draw the number line. Here's 0, my reference point. And we're going to locate these two numbers. Okay, now let me actually move my 0. Oops, there you go. Because these are negative numbers, I'm going to make 0 to be here, a little to the right, so I have room for negative 8 and 10. So arbitrary point, call that negative 8, and let me call that negative 10. Okay, so once we have these numbers that make the factor 0, we're going to actually plot them on the number line. Now, if the inequality is such as this one, is greater than or less than, doesn't make a difference. If it's greater than or less than, the numbers that we get, once we set the factor equal to 0, namely these two numbers that we get, this one and this one, right? These two numbers. We're going to show them on the number line, and we're going to show them using open circles. So here's an open circle here, open circle there. Now, the significance of open circle is this. If I plug in, for example, a negative 8 into this inequality, what do you think is going to happen when I plug in a negative 8 in here, and as well as in this one? Well, negative 8 plus 8, let's do that. So I have negative 8 plus 8 times negative 8 plus 10. And this will be 0, true? 0 times whatever is 0, and at that point the expression reads 0 is greater than 0. Now this is not true, right? This is a false statement. 0 is equal to but not greater than itself. So, and that's the significance of open circle. That means these numbers, the two numbers I circled, are not part of the solution. So once we get that straight, now we can move on to the next step. The next step is to pick what we call a test point. Okay, a test point or a test number point, or here I have a test number. Okay, and this test number could be any number that you want to choose. Okay, so again, I'm going to choose a test point here, which is a number, any number of your choosing. The only two numbers for this exercise I cannot pick. I cannot pick the numbers that make the factor 0. So I cannot pick negative 8 and I cannot pick negative 10. These two we cannot pick. So any other number would work. So here I'm going to choose 0 as my test point. Now we're going to plug in 0 into the original inequality. That's going to be 0 plus 8 times 0 plus 10. 10, right? There you go. And the product is going to be 8 by 10, which is 80. And of course, 80 is positive, true? A positive number. The magnitude of the number doesn't matter. 80 or 80,000. What we want out of this test point, what we're doing here right now, we want to obtain a sign that we will take with us to the number line. And there you go. So I'm just going to put plus, 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 plus here. Now, what does the plus, plus, plus means? That means anybody's test point, and you can try it. You can choose your own test points. As long as you pick a value or a number that's above negative 8, this product is going to end up being positive. So for example, pick 5, pick 2, pick 1, pick negative 3, negative 4, anything you want greater than negative 8. You should all get the same positive product, not the same number. I got 80, but a positive product. Okay, so that's what plus, plus, plus means. Now, I'm going to choose another test point. This next test point I'm going to choose, I'm going to actually pick a test point that is right there between negative 10 and between negative 8, right? Between these two numbers, negative 10 and negative 8. So I think, negative 9 would be a good number to pick. Okay, so that's what I'm going to pick. I'm going to pick my test point to be negative 9. TP, here it means test point of negative 9. So I'm just going to plug in a negative 9 now into the factored form. Negative 9 plus 10, negative 9 plus 8, that makes it negative 1. Negative 9 plus 10 is 1. And the product, of course, is negative 1. And this time, it is a negative product, right? Negative. So, between negative 10, negative 8, I'm going to put minus, 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 like that. And again, the significance of that is this. Any number, any test point you pick between negative 10, negative 8, I pick negative 9, you can pick negative 9.1, 9.2, 9.3, whatever. As long as it's between those two numbers, we should all get a negative product. And then last, I'm going to look at what's below negative 10 in this segment right here. Right, I'm over on this side now of the number line. Pick a test point here. My test point, I'm going to pick negative 11 maybe for this one. Negative 11 right in here. And let's see what happens to the sign. So I'm going to scroll up a little bit here. And this time my test point is negative 11. So I'm going to do a negative 11 plus 8, negative 11 plus 10. And negative 11 plus 8 is negative 3. Negative 11 minus 10 is negative 1. And the product is going to be 3. Again, is a positive product. So I'm going to put plus, plus, plus here. So see how that works? So this way we have partitioned or divided our number line into positive, negative segments. Okay, now, why did we do this? Once we have partitioned the number line into positive, negative segments, then we go back to the original inequality. You see this one? Number 14. Original inequality says we want products that are greater than 0, meaning products that are positive. Okay, well, how are we going to get positive products? So if we reflect back to our number lines, we can see that the positive products occur in this segment of the number line as well as in this segment of the number line, right? So I'm just going to highlight those on our number lines. There you go. Isn't this all positive? And this is all positive, right? So there we have it. Our shaded region is in the highlight yellow. This would be our shaded region. And this is shaded region. And we're just going to write the interval notation that corresponds to the highlighted segment on the number line. So the solution, therefore, to this inequality is from negative infinity to negative 10, parentheses, because remember at negative 10 we have open circle. And then we're going to say or, which means union with negative 8 to infinity. And there we have the interval notation for the solution according to what we have. Now, just to emphasize, let's write this note for you. Note, if inequality has less than or greater than, then remember on the number line that translates into open circle on number line. Okay, and if inequality is less than or equal to or greater than or equal to, this translates into solid or closed circle on the number line. There you go, whatever these are on the number line. Okay, so that's what our conclusion is. Let me just make that a little nicer for you. There. And with that, let's go to our next example. Okay, our next example, we're going to take a look at exercise now number 18 in the book. In exercise number 18, the expression is x squared plus x minus 2, and it's going to be less than 0. Remember the two things we must have. We must have the factored form, and we must have 0 on the right side. So both of those are present here. There you go. Remember, this was a must, right? That had to be a 0, and it is. Now, the thing we don't have here is factored form. So we need to factor that first. Now, the factored form of x squared plus x minus 2, it's going to be x plus 2, x minus 1, right? The two numbers, 2 and -1, the product is -2 and the sum is 1. 1 is the coefficient on the middle term, this term x, the coefficient is 1. We're going to make that less than 0. And next step, we're going to find the numbers that make each factor 0. X plus 2, 0. X minus 1 is 0. So from here, x is -2. From this one, x is 1. And those are the two numbers we got. So what are we going to do next? We're actually going to draw this number line now. Here's the number line. 0, my point of reference. Let's say this is 1 and this is -2. Now, the inequality is less than. True? Oops, sorry. I grabbed the highlight, but it didn't work. There. Inequality is less than. So that means these points, the -2 and 1, both of these are going to be open circles again, because those will make the expression to be exactly 0, and we don't want that. We want less than 0. And then following this, we're going to choose our test points, right? So our test points, I'm going to choose a test point here, pick one here, and another one here. So let's say I'm going to pick -3 here. 0 would be a good one here, easy point, and maybe a 2 here. Now, plug those into maybe the factored form or the original inequality. It doesn't matter. This would be the factored form. This is the original expression. Okay, I'm going to go in the factored form. Okay, so for this one, I'm going to get in the factored form a -3 plus 2, -3 minus 1. That's going to be -1, and -3 minus 1 is -4. The product is 4, right? 4 is positive. Because 4 is positive, I'm going to put plus, 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 plus here. How many pluses doesn't matter, by the way. Just as many as you like. You can fit into that segment. Now, next you can plug in a 0, a test point of 0 in here. I go 0 plus 2, 0 minus 1. That's going to make it 2. 2 times -1 is -2. And this time, this is a negative number, a negative value. And I'm going to put negative, 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 negative here. And finally, I'm going to pick a test point 2 in this segment. So that's going to be now 2 plus 2 times 2 minus 2 minus 1. And that's going to be a 4. 4 times 1 is 4, and that is positive. True? Positive. So it's going to make it plus, plus, plus. Now, if you noted, by the way, notice how we have these alternating signs. You go plus, minus, plus. And if you look at the one above, the one we just wrapped up, finished, we have plus, minus, plus. Now, would this usually happen? Well, the fact that it's plus, minus, plus is pure coincidence. But as far as alternating signs go, so I have positive sign followed by negative by positive. That's what I mean by alternating signs. See, they change, alternate, they change. This will happen every time. It will happen provided each factor repeats only one time. Now, we can generalize this if the factor appears even number of times, odd number of times, and so on. So, there is a way to generalize this, by the way, but all I want you to do at this point to keep it simple is just pick your test point and let the test point do the talking for you. But there are ways to actually determine whether the signs will alternate or not. Now, once I have this one, going back to the original inequality, right? The original inequality. Here, the fact that this is less than 0 means negative, right? Negative. So we're looking for negative segments on the number line. The only negative segment on the number line is this one right in here, which I'm going to highlight again. There you go. That would be like my shading of the number line. In the book, they use actually like a boldface kind of solid line. They boldface theirs, but I use highlights. And there you go. There's a solution. So now we're just going to write the interval notation for the solution. The interval notation is from -2, 1, and that's where the answer to this exercise is. Okay? So hopefully you follow this exercise as well. So we're done with this exercise. Now, let's take a look at another one in exercise number 24. Now, in number 24, again, we have a polynomial inequality. I have 5x times x plus 1 times x minus 1 greater than 0. Which means, what? Greater than 0 means positive, right? Okay. And note everything is in factored form, and that's all important. That's the all important 0 we want on that side, so which we have. Now, our next step is to actually pick the numbers that make each factor 0, right? x0 makes that factor 0. So here's actually a value, 0. X plus 1. What makes x plus 1 this factor 0? Well, -1 does. So here's -1, dot, dot, dot. And what makes this last factor 0 is 1. And here's 1. And again, it just so happens the one I picked, none of those have equal sign. The inequality is less than or greater than. There you go. But if this one had the equal sign here, right? If the equal sign was there, then we make these points that we find by setting the factor 0. We'll make these solid points. But for now, that's not the case. So, what do I need next? Next, I'm going to need my test points, right? So I'm going to pick -2. I cannot pick 0 anymore. Let me make these, in fact, open circles. Remember, your test point, any points of your choice, other than the ones that make the factor 0. So I'm going to have to pick maybe -1/2 here, and in here I'm going to pick 1/2. Outside of that, I'm going to pick 3. Or you can pick 2 if you like. So just to be different, I pick 3. Now let's try these. I'm going to try -2. So that's going to be 5 times -2, -2 plus 1, and -2. Let me clear that one. Okay, and it's -2 minus 1. Okay, now just to do the arithmetic, 5 times -2, that's going to be -10. -2 plus 1 is -1. -2 minus 1 is -3. And negative times negative times negative is going to be -30. And so the product is negative. Again, don't worry about the 30, the number 30. We just want a sign out of this work. So negative. My test point was -2. So at this point, I'm just going to go negative, 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 negative. Now, you can try these test points I have. I'm not going to try them because it's going to take time, and I know what it's going to do. But please, if you want, try -1/2 here, 1/2 here, and try a 3 in here. So, for example, for 1/2, you're going to put 1/2 for x here, 1/2 for x here, and 1/2 for x here. Then multiply these numbers you get, and I bet you your sign, all said and done, your signs are going to end up being like this: positive, negative, positive. They will alternate. And again, because I only have single factors, I don't have any factor that's repeated, let's say twice, 4 times, whatever. So for that reason, I went ahead and did a shortcut here. Now, remember, we are interested in positive, right? Right in here, we want positive products for this polynomial. Well, where are we going to get positive? It's in this segment of the numbered line and in this segment, true? So we're just going to write the solution that goes with that. The solution to this exercise is going to be -1, 0, union. The union, this symbol means or. That's all that means. So the solution is in the interval from -1 to 0, or you can find that solution from 1 to infinity, right? Remember, this goes indefinitely in both directions, like that. So again, this is the part of the number line. Oh, We have positive, and this is the positive segment of the number line. That's the solution to this exercise. And we are good with this one. Now so that's enough of polynomial inequalities. Next, we're going to actually look at what the book calls, or the topic is, the rational inequalities. So that's what we're going to look at next. We're going to look at rational inequalities. Now, the word rational here, by the way, remember, when we think of rational in mathematics, we are thinking fractions. That's what we're thinking of. Okay, so that's exactly what that is. Oops, I don't know what I did. Fractions. There you go. Now, let's go right to our exercise to see how this works. Number 38 in your book. In this exercise, we are given x minus 1 over x minus 2 is less than or equal 1. And I believe this is very close to one of your homework problems. Okay, now remember, we need to have 0 on the right side, which we don't. Right now there sits a 1. True? This is not a 0, that's a 1. So what am I going to do? Well, we're going to subtract 1 from both sides. X minus 1 over x minus 2, negative 1, less than or equal. And I'm going to emphasize on the 0 here. You see that? That's why we had to do that. So we're done with the right side. Now let's focus on the left side. On the left side, we need to combine a fraction and a non-fraction. There's my fraction, minus. Now the non-fraction, 1, I'm going to write this 1 as x minus 2 over x minus 2. True, that's still 1. The reason is because I'm about to get LCD. Otherwise, I wouldn't be able to combine the fraction and the number. Now, keep in mind also there's a negative between them. True? So my next step, I'm actually going to choose the common denominator, x minus 2. And the numerator is x minus 1, negative of the entire numerator of the second fraction is what's being subtracted in here. Okay, now I can work the numerator this way. This becomes x minus 1, and then it's going to be negative, and negative times negative, positive. First, it's going to be negative of x, and then positive 2, divided by the denominator, x minus 2 less than or equal 0. Okay, and then from this, I'm going to combine the like terms in the numerator. When we combine like terms, these add to 0. The x's are opposites, opposites add to 0. And then I have a negative 1 plus 2 that makes 1 divided by x minus 2 less than or equal 0. Now this is actually the correct form, right? This is the right form that goes back to what I had in the beginning of this section. Let me scroll up to the top, and there you go. Right up here. Remember, we must have, I'm reading the number 1 and 2, we must have 0 on the right side, expression on the left must be in factored form. And in fact, we have accomplished that. Okay. And let me go back down, 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 and there you go. This is where I'm at now. Okay, so what do we do now? I got the 0 on the left, the expression on the right side I have 0, and on the left I have as factored as it can be. So we're doing exactly what we did before at this point. So here's my number line. This is my number line. And we're going to see, let's see, what makes x minus 2 in the denominator 0? A 2, doesn't it? So this is a 2. Now, this is very important, folks. I did mention if the inequality has equal sign, which it does here. If it has equal sign right here, then we need to make these points that make the factor 0, we turn them into a solid point. True? Well, in this case, because a 2 in the denominator makes fraction denominator of the fraction 0, correct? And because division by 0 is undefined, I'm going to make this an open circle, right? Because again, at 2, you're going to get 1 over 2 minus 2, which is 1 over 0, and it is undefined. So it is for that reason that you have an open circle here. Okay. Otherwise, we'll make it a solid circle or a closed circle. Now, there is no factor in the numerator. There's no variable that can make the numerator 0, 1. That's always positive. So let's pick our test point. My test point, I'm going to let this be my TP. TP means test point. So I'm going to plug in a 0 in the fraction. 0 minus 2 is going to be negative 2. The fraction is going to be negative 1/2, isn't it? 1 over negative 2 means negative 1/2. Let me just show you that. So I'm picking test point 0. 0 minus 2, 1 over negative 2. There you go. That's what I meant. That's negative 1/2, which is negative, clearly. So below 2, we're going to put negative, negative, minus, minus, minus sign. Means no matter who picks what number, as long as it's less than 2, we will all get a negative fraction, which implies above 2 is going to be positive. Feel free to pick a test point. If you don't believe me, I don't know, pick something like 3 maybe. 3 is your test point, and see that indeed it does that. So less than 0, right? When we say in the original problem for this one, we're looking at less than 0 means negative. We're looking for negative fractions. And the only negative fraction that appears would be in this segment of the number line, isn't it? It's just that portion of the number line right there. That's going to be the shaded segment on the number line. Now, the interval notation for what I just shaded here, right? For this shaded portion, for this segment, the highlighted now section or segment of the number line. This is going to be from negative infinity, comma, up to 2, parentheses at 2, parentheses negative infinity, and that is a solution to this one. Okay. Hopefully you were able to follow this one. You can, of course, always watch how this thing unfolded from the beginning, I guess, right? That's a good thing about these lecture videos. You can watch them at your pace and watch them as many times as it takes. Okay, let's finish off the section, folks. I'm going to finish this off with number 40. In exercise number 40, I actually picked an exercise where I have the factored form of the top and the factored form of the bottom. Of course, the bottom is a single binomial x plus 3 greater than or equals 0. So this one has both the requirements that we need here again, right? It has 0. That's the first and foremost. Okay. And it has the factored form on the left. So we're good to go on this one. Let's go right to the number line, and we're going to pick the numbers that make every factor 0. In the denominator, a negative 3 makes this 0, doesn't it? Negative 3 makes this denominator 0. Sorry. Negative 3 makes that 0. Now, because it's in the denominator, remember, folks, this is going to be an open circle. Now, anything that's in the numerator, anything means numbers that make the factors in the numerator 0, are going to be solid lines, right? And the reason they're going to be solid, not lines, I'm sorry, solid points is because of equality. Okay, so what makes x plus 4 0? A negative 4. So this is going to be my other point, negative 4. And at negative 4, I'm going to have a solid point there. And what makes x minus 1 0 is a 1. So let's let this be 1. And that's going to be solid or closed circle. There you go. That means those points will give you exactly 0, which is a true statement for this exercise. And then let's go with my test points. I'm going to let this be my test point. 0 is a good test point, right? I'm going to let that be my test point. Always makes things easier. So I'm going to plug in a 0 into that original inequality. 0 plus 4, 0 minus 1, all over 0 plus 3. 0 plus 4 is 4, 0 minus 1 is negative 1, divided by 3, and that's going to be negative 4/3. Okay, now negative 4/3. Throw the 4/3 out. What we want is the sign, negative. The fact that this is a negative ratio enables me to create my sign segment on the number line. There you go. They call this a sign chart. I'm doing my sign chart. There. And just to go through the motions, let's say I'm going to pick a test point here to be, I don't know, 5. How about that? As long as it's bigger than 1. So I'm going to go 5 plus 4, and then 5 minus 1 over 5 plus 3. Okay. 5 plus 4, 9. 5 minus 1, 4. And 5 plus 3 is 8. Again, this is positive, isn't it? I don't know what the number is. But it's going to be positive. We know that. That's all we care about. We don't care about the magnitude, the absolute value of the number. So positive, that enables me to create my sign chart in that segment. And based on what I said, because the factors are single and they don't repeat, I'm going to make these alternate. Feel free to pick a test point like negative 3.5, negative 5, and see that I did this correct. Now, nearing the end here, greater than 0, that means positive, right? So we are looking at positive segments on the number line. The positive segments on the number line, I have 2 segments of them. One is here, the other one is right in here between negative 4 and negative 3. And we're going to write those as our final solution. So the solution to this exercise is going to be bracket, negative 4, comma, negative 3, parentheses, right? Because we have open circle at negative 3, or, which means union with bracket 1, comma, infinity. And that is the final solution to this one. And again, hopefully you followed this. It's not complicated. It's just you got to make sure, like everything else we do, that you follow step by step and make sure things are in appropriate format before we do this. And with that, we are done with this section and in fact with chapter 11.